in example 4, we are going to revisit the two homomorphisms that we already saw in example 3, and we're going to examine a little bit more the set of cosets of the kernel of those homomorphisms and the homomorphic images of those homomorphisms. So we already saw that there was something going on with the cosets of the kernel and the images, like every element in the same coset was mapped to the same image, and so we suspect that there's something going on right there. So let's look at the two examples in more detail. So the first one was phi from z6 to z6 defined by phi of x equals 2x mod 6. And we know what the kernel looks like, so the kernel of that map, of that homomorphism, contains 0 and 3. And so we had the other two cosets, 1 plus k, and that contained elements 1 and 4. And then 2 plus k was a set containing 2 and 5. All right, so now let's look at the Cayley table of first the factor group z6 mod our kernel. Okay, well, in our kernel, in the factor group, the kernel is the identity. So we have k, 1 plus k, 2 plus k in the first row, and then also in the first column. Then what do we get if we take something in 1 plus k and add it to something in 1 plus k? We get something in 2 plus k. And if we take something in 1 plus k and add it to something in 2 plus k, we get something in 3 plus k, but 3 plus k is the same thing as k itself. So we get k, and for the same reason, we get k if we take something in 2 plus k and add it to 1 plus k, and if we take something in 2 plus k and add it to something in 2 plus k, we get something in 4 plus k, but 4 plus k is the same as 1 plus k, so here's our Cayley table. Now, what about phi of z6? What does that look like? Well, it's our group under addition that contains 0, 2, and 4. And 0 is the identity. So we have 0, 2, and 4 in the first row and in the first column. And then what is 2 plus 2? That's 4. What is 2 plus 6? Mod 6, that's 0. What is 4 plus 2 mod 6? That's 0. And 4 plus 4 mod 6, that's 2. So when we're looking at this, what do we notice? We have two Cayley tables that have different things in them, two groups with different things in them, but the Cayley table has exactly the same structure. And so it seems like that these two groups are isomorphic. And yeah, so it appears that our factor group, z6 mod the kernel, is isomorphic to the image, to the homomorphic image in our example. And what would that homomorphism look like? So since I already used phi, I'm using psi. What's psi of a plus k? Where does it get mapped? Well, a natural way to think about it is, well, everything in one coset gets mapped to whatever an element in that coset gets mapped to under phi. So that would be psi of a plus k would be equal to phi of the element a. We can visualize this in a diagram over here on the right. So over here we have z6 and z6, and so we have our homomorphism phi visualized the way we've already seen it before. But then in addition, we have our factor group at the bottom right here. So we see we have k, we have 1 plus k, and we have 2 plus k. Our three cosets are the elements in that factor group. This is our group Z6 mod K. Okay, so this new map that we just defined, the psi map that maps A plus K to phi of A, we can visualize with arrows going from each coset to the image under phi, where every element in the coset gets mapped. And so we see in my red arrows right here, that is that new map, psi. And where does it map to? Well, it maps to the image under phi. So that is the set, or the group, phi of Z6. So if we declutter a little bit, we have the following thing going on. So we have Z6 going over here, mapping to Z6. Or rather, actually, we don't want all of Z6 really. We are just going to the image because there are 3 elements that we never hit. So let's just ignore those. So we really can simplify by saying Z6 maps via phi to phi of Z6, its image. But then we also have this map that takes each element in Z6 to the coset mod the kernel. So we have this map to the factor group. And we're going to call that one, let's call that one gamma. So it just sends an element to its coset. So gamma of A is mapped to A plus K. Okay, and then we have this new map, psi, that takes a coset and maps it to the image under phi. So this is a little bit of a simplified map illustrating what's going on up here in our first diagram. We have the same thing going on for our second homomorphism in part B. So I already wrote that out, but it's exactly the same thing. So we had theta, a homomorphism from U16 to U4, and it was defined by theta of x was x mod 4. That was part B of example 3. And the Cayley tables are over here on the right. And they look identical, right? I mean, not identical, but they again show that the relationship between our factor group U of 16 mod K and our homomorphic image phi of U of 16. And we have the same diagram that we can draw where all the elements in one factor group, in one coset, are mapped to the same image. And so again, we have this relationship and this new map, psi, that goes from our factor group to our homomorphic image. So we see again that our factor group, U of 16 mod K, is isomorphic to, in this case, theta of U 16. And this is true in general. So these 2 examples are we are going to generalize them in the next theorem, which is called the first isomorphism theorem, and we'll talk